Welcome! In this series of videos, we will cover the design and implementation of a project, from initial design through coding and development to testing, using either the PowerBasic Windows or console compilers. Today we will start a new project to look at the use of AI for data analysis. Artificial intelligence has been much in the news lately, mostly for its ability to extract information from unstructured data and reformat that data in a form you actually want. However, in business, much of data is stored in structured format, in things like Excel spreadsheets and SQL databases. So what we're going to look at today is the ability of a couple of large language models to handle structured data and to pull information out of it. But first of all, we'll need some data. To avoid using live production data, we're going to create a PowerBasic application whose task in life it will be to generate simulated data. In this case, the kind of data that will be held inside a ticketing system, keeping track of issues raised by users within an organization. The application we're going to create here will be able to be run either under the Windows console compiler or the Windows compiler, as we're going to be using a graphics window. So what you see on screen here is the console compiler's integrated development environment. I'm going to be doing the coding in here, but as I've said, you should be able to compile and run this in the Windows compiler as well. So first of all, we're going to turn off the console. This command will turn the console off if we're actually compiling using the console compiler. If using the Windows compiler, this command will be ignored. Next, we want to set the number of records that our program is going to generate. So I'm going to set up three constants: true, false, and max records. The true and false are to handle our Boolean decisions later on in the program. Max records is the number of records we're going to create in our structured data. So the output from this program will be 1500 records. Next, I'm going to create some global variables to allow us to handle our graphics window and to start and stop a clock, indicating how long the application takes to run. So with this out of the way, we're going to bring in a couple of include files. First of all, to handle files, and second, one we did in a previous video to handle random data generation. So here's our PB file handling routines library and our random routines library. We'll cover the functions within these libraries when we get to them. Next, we want to set the name of the output file. This will contain the 1500 records in a standard CSV format. And we're going to call our file randomdatafile.csv. In our PB main function, the first thing we're going to do is to set up a font to be used within our graphics window. This can be quite easily done by using the font new command. So we're going to be using Courier New 18 point. And we send the output of that to our global variable DW font. This global variable can be used at the end of the application to clear out the memory used by the creation of our font. So next, we want to build our graphics window. We'll create a function whose job in life it will be to perform that function. We'll create that function in a moment, but we'll push on and complete the coding within our PB main function. So having created our graphics window, we now want to generate and save our output data, and we'll create another function to perform that task. So we'll call that function GenerateFile, and it will take a single parameter, which is the path and the name to our output file. We're not designating the path, so the output file will be created in the same folder as the executable. And we're updating our graphics window by using another function, setProgressText, to say that the file has been generated successfully. If this function returns false, then we'll want to say that for some reason the file has not been generated. And after we've run the GenerateFile function, we will print a message out to say we're exiting in 10 seconds, and then close the application down. So before we go any further, let's just save this application to disk. And we're calling it GenerateData. In this folder, we have our two libraries, the Random Routines library and the file handling routines library. We'll copy these into our IDE so we can see the code held within them. So our first task now is to create this build graphics window function. And this is a very straightforward function. It has only one local variable, which is text. And it will print on our graphics window the words generating data. So the graphics window command will create our window, given our text, its location on screen, its width and height, and it will save the handle of that window to the GHWin global variable we created at the beginning of the application. The graphic attach command is then used to instruct PowerBasic that all graphics commands will be sent to this window. And we're setting the font on this window to the font we created earlier. And we're creating a graphics box on the screen. So now that we've created the function to create our graphics window, the next task is to go to the generate file routine and create it. So here is the skeleton of our generate file routine. As you will see, we have a couple of local variables, header and data, and a number of arrays. These arrays are going to hold our seed data, as we want the data within the output file to contain a number of columns of information. We need to get that data from somewhere. So we're going to feed in a number of files to our application. It's going to load those files into these 4 arrays. And then information can then be extracted randomly from the arrays to form up our data. So let's have a look at the files we're going to use for the seed data. So here are the 4 CSV files we're going to be using for seed data. Let's open up the first names file. This file contains a number of columns, and it has over 9,000 records returned. The column we're interested in is the first forename. This data is going to be loaded into the first name array. And if we have a look at surnames, we'll see it has a single column and 1,000 records. So we're going to form up a user's first name and surname from these 2 files held in arrays. Additionally, we have a sites array, which will contain, in this case, just 15 records. So the data we're forming up will have users spread across 15 different sites in our organization. And the final array is the type of asset, in this case, that the user has raised some issue on. And we have 15 records in here. Of course, all of this is dummy data. But we're going to use it to generate 1,500 records that we can then interrogate using AI. So our next task is getting the data held in all those seed CSV files into our arrays. So I'm going to create a number of local variables to be used for pulling that information out. The plan is we want to generate 90 days worth of information, dating from the 1st of January 2025 for 3 months hence. The reason for this is we want to generate automatically the date and time that the call was raised, and also a random date and time closed. So these are our variables we're going to be using to hold the information on each individual column of each record. Next, we're going to set 2 variables, one to say that we're using the UK date format, and one for the seed date, the date from which we will start our processing at. If you wish to generate dates in the US format, you merely have to change this variable from UK to US. Next, we're picking up our start of the timer. This will allow us to measure how long the application takes to generate our 1,500 records. As the output from our application is going to be a CSV file, we'll need a header line. So we're going to populate the header variable with the column names. And here are our column names. We want date opened, time opened, username, the user ID, which will be formed of the person's first name, 2 characters of their surname, and a number. Then we have the site and the date and time closed, and finally the asset which the ticket refers to. we're making good use of a number of inbuilt PowerBasic constants. $DQ gives a double quote character, and $QCQ gives you a double quote, comma, double quote. This saves a lot of time when making up these kinds of headers and populating CSV files. Next, to ensure that our output file is not going to already exist, we're going to wipe it by using a kill command. Embedding this within a try-catch block will allow us to, if the file exists, kill it off, and if the file doesn't exist, it will not generate an error that stops the program running. Next, we're going to use one of the functions within our file handling routines library, append to file. This will add to a file that already exists or create a new file and put the data into it. So this will write our headers out to our output file. Next, we're going to populate all of our arrays. And there's a function in our random routines library which will do this quite nicely. Build array takes a number of parameters. First name is what appears on our graphics window. The next parameter is the name of the array we're going to be populating. The next parameter after that is the name of the CSV file that's going to feed into this array. The next parameter is the column within the CSV file that we're going to pick the data out of. And the final parameter is the delimiter inside our CSV file, which is of course a comma. We're going to do this for each of the arrays. So as you can see, we have 4 arrays being populated: the first name, the surname, the sites, and the assets. Now that we've populated arrays, we're ready to start generating our records in the output file. First, we're going to populate the days variable with the value 0. As we generate data, it's either going to be on the 1st of January 2025 or 90 days hence. So we're going to use a random number generator to generate a value between 0 and 90, and that will be the day we're actually going to be putting in to our CSV file. So we're going to do this in a for next loop. So first, we're going to set our progress bar at the value 1. And as our max record constant is 1500, it will move between 1 and 1500. And next, we will populate our days variable using the rnd command. It takes 2 parameters, the minimum and the maximum value we wish to generate. So it will give us a number between those 2 values. Now we can work out when the date the ticket was opened. And we're going to use 2 functions in here, one called getDate and one called getTime. The getDate takes 3 parameters. First of all, the seed date, then the date format, and finally the number of days we have just generated. It will pull back a date in either US or UK format, depending what you set the date format to be. The time will pick a time during that day. There are a number of functions within our random routines library. One of those is getDate. If we have a quick look at that, it will take in our seed date, our date format, and the number of days, and it makes use of the iPowerTime class. It tests the date format. If it's US, we pull the information for year, month, and day out of our seed date. Otherwise, it does it in the UK format. We then use the PowerTime class to populate the new date. We then add the number of days onto that date, and we return that date to the calling routine. The getTime function takes an optional parameter. Initially, we're not passing the parameter at all. Therefore, if it's missing, then the hour and minute starts at 0. And we're using the rnd command again to work out the hour and minute of the time to be returned. This allows us to use this one function to generate a time that is either completely random during the day or appears at some point after the initial seed time. Our next task is working out when the ticket was actually closed. So we're generating a random number between 0 and 5. If we generate 0, then the ticket was closed on the same day it was raised. Any other number is a day hence. So we're going to use the getDate and getTime functions once more to work out these date and times. Next, we're going to generate the username. And we're going to be calling another function, getArrayValue, which is in our random routines library. This will pull back a random value from our first name array. And we're adding on to that the random value from the surnames. As all the data in the surnames array is uppercase, I'm changing this to mixed case. So the first character of the word will be uppercase and the rest lowercase. So now we have the user's name, we can then start to generate our output data. So now we're populating the string, which is going to be the CSV record, starting with a double quote, followed by the date opened, the quote, comma, quote, time opened, then the username, and we're using another function we'll come back to, the getUserID, to get the username. We're getting the array value from the sites, the date closed, the time closed, and a random value from our assets array. So now that we have that in a single string, all we need to do is to push that out to our output file. Again, using the append to file routine. So this should have populated our output file. So we will close off our timer and put the duration out to our graphics window and return true to the calling function. So there's a couple of more functions we need to generate in here that we've actually called, which do not yet exist. setProgressBar and setProgressText. And here is the first of these, setProgressBar. This will draw the progress bar on our graphics window. Nothing particularly complicated in here, just a matter of drawing a graphics box, setting position, and then printing the text. And the setProgressText function is taking a piece of text and pushing it onto the graphics window. So we should now be ready to run our application, and this should generate our data. So let's double click on the exe and see what happens. And there is our graphics window, and we appear to have loaded all the arrays, and we're now stepping through our 1500 records. And once this is complete, we can have a look to see what we have. So there are our 1500 records generated, and we can see we now have a random data file.csv. If we double click on that file, we can now see our display of 1500 records. We have a header line and 1500 individual records showing the date opened, the time opened, a user's name, a user's ID, the site at which the user was located, the date closed, the time closed, and the asset the user was raising a ticket about. So we have 1500 random records we can now feed into our AI system. So let's power up our AI box and try to extract information from this structured file. So here we are loaded up into a local LM Studio. And we're going to pick the model we want to use, and we'll pick the OpenAI GPT 120 billion model. This will take a moment to load. Once it's loaded up, we're then going to point it towards the file we have generated in PowerBasic, the 1500 CSV file, and we're going to change the reasoning from low to medium. Right, our model has now loaded, so we're going to put a query in. So let's first of all add our file to this chat. And there is a random data file. So we'll add that in. And we're going to do something fairly straightforward first of all. We know there are 1500 records and one header. So let's ask how many records are in this CSV file. It's telling us it's unable to determine a number of records because it doesn't have access to the CSV file, even though we've just given it the CSV file. So let's change our query to mention the name of the file. Now we've got the name in there, let's see how it does. Yes, we're obviously struggling because although we've uploaded the file, for some reason it cannot see the file. So not terribly successful in this particular model. Let's switch to using an online large language model. So now we're in the Claude AI. Let's add our file and then go through the same process. So there's our random data CSV. We've now added it, and let's ask the same question. And here we have more success. There's obviously a limit to what you can do with large language models, but this particular large language model does more than just reason. It has inbuilt calculation abilities. So it correctly identified that there were 1,500 records plus one header row. So let's see if we can do a wee bit more and get it to interrogate the data. So I'm now telling it what the header row actually contains. And we're asking, can you count the number of records there are for each month using the date opened column, given that the date is in UK format? It's important to specify date formats to these type of models, as it may well assume the US date format. So let's try that query and see what we get back from our structured data. And as we can see, it's actually running a Python script. And there we have some data coming back for January, February, March, and also April, giving us a total of 1,500 records. So let's see if I can pull some more information out using another query. So we're now asking it, can you count the number of records for each asset using the asset column? And again, I'm not speeding up this, it's running in real time. So it should give us a breakdown of the records by asset column. And there is the data. Admittedly, this is the kind of query you can do in Excel. So let's see if it can handle more. Can it count the number of records for each asset per site? And again, it appears to have come back reasonably well. It's giving us a breakdown for each site and how many records they have of each asset type, again totaling 1,500 records. So let's try it based on the user. So we're asking which user had the most records per month. Now remembering, we don't actually have a column called user. We have username and user ID. So let's see what it makes of this. Again, since our generated data is fairly anonymized, we have only a small number of records for individual users. And again, it's come back with reasonable responses. So let's try which site had the most records per month. And again, its ability to actually use Python to number crunch is very useful. So we can see here that Hub 1 had the most number of records in January, Airport 2 the most in February. So let's ask it how many records were opened and closed on the same day. And there we go, there were 233 records opened and closed on the same day, which represents 15.53% of all records. So looking at this, I would say that the Claude AI, with its access to Python, is a good tool for handling this kind of structured data and being able to answer free text questions on the data itself. This facility is particularly useful for users who are not trained in the art of writing SQL queries or writing applications, or even understanding Python. However, as you saw, the local AI we're using was not up to the task of doing much with the data. Perhaps we need to pick a different AI model with some access to Python tools. However, we'll leave that for a later video. That's it for today. Thank you for watching.
Thank you for watching today's video. Please feel free to click on the link in the description below to discover more videos.